There are a lot of different chemical formulas, a lot of different compounds. We represent them with formulas because if they all had just common names, it would be an awful lot of stuff to memorize. And so the formula is like a shorthand that tells us how many atoms of which elements are in the compound. So we use a subscript following the element symbol to tell how many atoms of that element there are. So H2O, this means there are 2 hydrogen atoms and 1 oxygen atom. We don't write a subscript 1. Chemists seem to have a thing about writing the number 1. I figure, why write a 1? If there wasn't 1 oxygen, I wouldn't have written the O, right? So I wrote the O, that's good enough. If there's more than 1, I'll write a number. So H2O. Carbon tetrachloride has this formula, CCl4. So there are 2 elements here, carbon and chlorine. There's 1 carbon atom for every 4 chlorine atoms. You need to be a little bit careful because capital I's and lowercase l's and number 1s can look a lot the same. So you just kind of have to watch out for that. Because sometimes people would look at this and say, oh, well, that's carbon, carbon, and 4 iodines. But if that were the case, we would write it differently. We would write C2I4. When I write things by hand, I always put the little serif things on top and bottom to make sure that we see that it's an I. There are different types of chemical formulas. We will talk about empirical, molecular, and structural formulas. And they're used in different situations where different amounts of information are needed. So an empirical formula gives the relative number of atoms of each element. This is going to give us the lowest ratio. And this is useful in some situations. A molecular formula gives us the actual number of atoms in a molecule of that compound. Empirical is a word that means from experiment. And so this is something that's determined experimentally, and we'll actually do a lab where we find the empirical formula of a compound. The relationship between the empirical and the molecular formula is that the molecular formula is some multiple of the empirical formula. It could be 1 or 2 or 3 or 5. So let's look at some examples. C4H8. This is the molecular formula. And so if I look at the ratio here of carbons to hydrogens, I see that it's 4 to 8. That ratio can be simplified. I can divide both of those numbers by 4 and come up with the same ratio. 1 to 2 is the same ratio as 4 to 8. This is the empirical formula. The empirical formula has the lowest ratio in the subscripts. B2H6. Again, 2 to 6 is a ratio or a fraction that could be reduced. If we divide both of these numbers by 2, we're going to get 1 to 3. So BH3. This is the empirical formula. For CCl4, a ratio of 1 to 4 cannot be reduced. And so here the empirical formula is the same as the molecular formula. Any questions? And then there's the structural formula. Structural formula gives us more information about a molecule because it shows us how the different atoms are actually connected. There are single, double, and triple bonds, and so we use single lines for single bonds and double lines for double bonds and triple lines for triple bonds because it just seemed to make sense. So for H2O2, this is hydrogen peroxide, the structural formula would look like this. This is showing that the hydrogen is connected to one of the oxygens, and that one's connected to another oxygen, and that one's connected to the second hydrogen. Now, not knowing anything about how molecules form, there are lots of different ways you could show those things connected, right? You could, well, let's not do that. You could do something like that, or you could put the hydrogens in the middle. There's lots of different ways you could connect those four atoms. Just because you can draw it on paper doesn't mean it happens in real life. As it turns out, neither of these things exist. But sometimes there are multiple ways that do exist, and so then the structural formula gives us the information that we need to tell us which compound we're dealing with. Which formula we use depends on how much we know about the compound and how much we want to communicate about the compound. The structural formula gives us the most information, but it's also the most difficult to enter into a computer. It can get pretty tedious at times. The empirical formula communicates the least amount of information. But if that's all we know about it, then it's still useful. Most of the time we use molecular formulas. So here's a practice. Write the empirical formula for the compounds represented by the molecular formulas. So what's the empirical formula for C5H12? It's the same as C5H12. A ratio of 5 to 12 cannot be reduced. How about Hg2Cl2? Just be HgCl. And how about C2H4O2? CH2O. Good. Any questions? Yes?
What does hydrolyzed
Hydrolyzed
mean?
means a bond has been broken by a reaction with water. Another way we can illustrate or indicate different chemical compounds is using molecular models. This gives us a better sense of the shape of a molecule. And of course, there are different types of models. One is a ball and stick molecular model. Here the atoms are represented as balls, the bonds are sticks, and then we connect them. It's like scientists' tinker toys. And we have molecular model kits, and we'll get them out occasionally. The balls are typically color-coded to indicate specific elements. This is just a common color scheme. You don't have to memorize that. But usually we'll see that white represents hydrogen, and black represents carbon, and red is oxygen. And if you remember all those little pictures we've seen of the Mickey Mouse head water molecules, they're red and white. And so we tend to use these colors throughout the book as we illustrate the different molecules. So here's, this is the compound called methane, and here we see the different types of ways we can indicate this. Here's a molecular formula. This also happens to be the empirical formula because you can't reduce 1 to 4. This is the structural formula showing us that all 4 of those hydrogen atoms are connected to the carbon. This ball and stick model gives us a better idea of the shape. It's got a tetrahedral shape. And then we have a space-filling model. This most accurately represents the true shape in terms of how it fills space. But in a complicated molecule, this can be a little difficult to look at because it's all bulky in the middle and you can't see what's going on the other side. The nice thing about the ball and stick is there's a lot of open space, and so you can see through and see what's connected a little better. But if we were able to, get pictures of methane, it would probably resemble this more than any of these other things. Here's another table, just giving some more examples, some different compounds, and then giving you the empirical formula, the molecular formula, structural formula, ball and stick, and space filling. And you can see here with this glucose, if you're just looking at that space filling model from one side, you'd have a hard time figuring out how many carbons, hydrogens, and oxygens are there because you can't see through it. And on this one, it's a little easier to see. Any questions?